Okay, so here's a picture of a histogram. And in the course of checking out our histogram right here, let's try to understand what it is that's going on and trying to make this as best as visible possible. Okay, given that it's a tiny thing on some of the monitors you're using. So the probability of a 0 here is 0.17. The probability of a 1 is 0.36. The probability of a 2 is 0.31. Ziva, quiet. The probability of a 3, I'm really not sure what that says. That's kind of tough. I'm also not sure the probability of a 2. And the probability of a 4, I guess it's like 0.02, I guess. I'm really not 100% sure. But we're going to do the best we can given this. So what we're looking to do here is to see, first off, remember these things about discrete probability distributions, okay? All probabilities have to be between 0 and 1 in order for something to be termed a discrete probability distribution. Clearly, all of those are between 0 and 1. And the probabilities pictured, or the sum of the probabilities has to be exactly 1. And the probabilities pictured are the probability of a 0, a 1, a 2, a 3, or a 4. There are no 5s, okay? So the question that I'm going to ask is this a discrete probability function? And to be honest with you, the first time I did this, I didn't think it was. But then I looked at the values, and I think it's a little hard to tell exactly what some of these bar graphs are. So if I gave this to you on a test, what I would do is I would accept either a yes or a no answer as long as when you justified why, hey, quiet, Cash, as long as when you justified why, then we would know that it is or is not based on what you said, okay? So a little stop and start. Tell me if this is a discrete probability function. Okay, so I added them up the first time and I actually came out with 1.02. This time I did it again and I said, okay, well, let me just be a little more generous with the numbers. In the first case, I said its probability of 0 is 0.17. The probability of 1 is 0.36. The probability of 2 I put down as 0.31. The probability of 3 was 0.14. And the probability of 4 was 0.02. So I'm not 100% sure that those were right. And for argument's sake, if you had said the probability of 3 was 0.13, and then you added up to 0.99 and said, no, it's not discrete, I would accept that fully because this is difficult to read. But the way I did it, it did add up to 1.0. And the first time I did it, I think it added up to 1.01. So any way you look at it, as long as your justification explains why, based on what you perceive the values to be, I would accept it. Okay? Next example. Suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of the time. 2 days a week, 15% of the time. 1 day a week, 4% of the time. And no days of the week, 1% of the time. Suppose 1 week is randomly selected. Okay? Let X equal the number of days Nancy attended classes. Okay? Then what are the possible values for X? Well, the values for X would be 3 days a week, 2 days a week, 1 day a week, or no days. So 3, 2, 1, 0. And suppose 1 week is randomly chosen, construct a probability distribution table called the PDF table. Like the one in example 4.1, we already did that one. The table should have 2 columns labeled X and P of X. And what does the P of X column sum to? If it sums to 1, then we know this is a discrete. If it doesn't sum to 1, then it's not discrete. This is a really important question because you have a homework question like this on each of the next 2 homeworks, and I want you to understand what you're supposed to do. You're supposed to produce a table. The table will have 2 columns. On the left-hand column, it'll say probability of 0, probability of 1, probability of 2, probability of 3, and on the right side will be what each of those probabilities are. So you're not really computing anything. You're just filling data into a table. Okay? Little stop and start now. Let's see what you got. Okay, so The answer to part A is the number of days Nancy attends class each week. Part B is 0, 1, 2, and 3. We have gone over that already. Now, the next part of this is the probability that she goes to class no days in a week. She does that 1% of the time, so that probability is 0.01. Now, the probability that she goes 1 day a week, she does that 4% of the time. So, 1 day, 4%, 0.04. 1 day, 4%, 0.04. 2 days is 15% of the time, so that's 0.15. And 3 days is 0.8 because it says she attends 80% of the time. So now the question is, does this add up? Is the sum of the probabilities 1? And the answer is yes. If you add them up, you get 1. And because of that, we would say that this is a discrete probability distribution. Okay. We're going to start the expected value next, but let me stop this video. That's the end of our instruction on what is and is not a discrete probability distribution.